This video shows the differential gear animation by FreeCAD Assembly4. When traveling straight forward, both shafts rotate same speed and the spider gear won't rotate. When turning right, the spider gears start to rotate so the left shaft rotates faster than the right shaft. On the other hand, when turning left, the spider gears reverse and the right shaft rotates faster than the left shaft. This is the information of gears for the differential gear set. Module is 2 mm with number of teeth, pitch diameter, pitch angle, gear face width and gear height. The offset distance is from the pitch circle to the base of the gear where the LCS is created. I will check the offset distance when I trim the gear. As the primitive gear is bigger than the 2 mm module gear needed, excess material is trimmed to form the gears I need. You can see the module is bigger and the apex position is based on the primitive gear. Let me go to FreeCAD and create these gears and animation now. Create a new file differential gear. Switch to part design. Create a new body. Rename it as Spider. Switch to Gear Workbench. Create a bevel gear. Module 2.5 mm, which is for the primitive gear, so I can trim it to a gear with 2 mm module. Teeth 10. Height 13.5 mm. Pitch angle 33.69 degree. Switch back to part design. Create a new sketch. Select XZ plane. Draw construction line from the vertical axis. Pitch angle 33.69 degree. The apex is 18.75 mm from the bottom. View section. Draw a horizontal line from the y-axis to the construction line. (10 mm long). Draw a straight line. Snap the point to the line. Make these two lines perpendicular so the back angle is same as the pitch angle. Distance of these 2 points is 1 times the module. So it is 2 mm. It is the module for the actual gear. Distance of these 2 points is 1.25 times the module. So it is 2.5 mm. Draw 2 construction lines. Use polyline to draw this shape. First along the construction line and then join another construction line. A horizontal line to the y-axis. A vertical line to the apex. The line ends at the dedendum circle. Make these two lines perpendicular. Define the face width as 10 mm. Make this line vertical. Close the sketch. Select the body spider and duplicate the item. Click OK to accept it. Rename the new body as side for the side gear. Duplicate it again and rename it as pinion. Duplicate it once more and rename it as crown. Hide the body's side, pinion, and crown. Open the sketch. Define the horizontal line as 17 mm long. Close the sketch. And cut the groove. The axis is the vertical axis. The gear looks good. Hide the spider gear and show the side gear. Edit the gear information for the side gear. Teeth 15. Height 8 mm. Pitch angle 56.31 degree. Edit the sketch. Delete the dimension 10 mm. Change the pitch angle to 56.31 degree. Distance to the apex is 12.5 mm. Radius of the pitch circle is 15 mm. Face width is still 10 mm. Set the length of the horizontal line as 25 mm. Check the offset distance, which is from the pitch circle to the base of the gear, where I will create a LCS. It is 2.08 mm. The height of the gear is 8.34 mm, which is what we need. Part of the shape is outside the primitive gear. Close the sketch and edit the gear size. Change the height to 9.5 millimeters. Now the primitive gear covers the shape. Close the sketch and cut the groove. The axis is the vertical axis. Hide the side gear and show the pinion. Toggle active body. Edit the sketch. Remove the dimension 10 millimeters. Change the pitch angle to 14.04 degree. The apex is 45 millimeters from the base of the primitive gear. The radius of the pitch circle is 9 millimeters. Edit the gear information. Height 21 millimeters. Teeth 9. Pitch angle 14.04 degree. Go back to the sketch. The face width is 11 millimeters. Set the horizontal line as 17 millimeters. Check the offset distance for mounting, which is from the pitch circle to the gear base where a LCS will be created. It is 0.61 millimeters. Also double-check the gear height. It is 11.6 millimeters as in the specification. Close the sketch to cut the groove. The gear is fine. Hide the pinion and show the crown. Toggle active body. Edit the gear information of the crown gear. Change the module to 3 millimeters. Teeth to 36 millimeters. Height 11 millimeters. Pitch angle 75.96 degree. Open the sketch to edit. First remove the dimension 10 millimeters. Change the pitch angle to 75.96 degree. Adjust the distance to the apex as 13.5 millimeters. Define the radius for the pitch circle as 36 mm. Delete this line. Use polyline to extend the line from the dedendum circle as the crown gear has a thicker base. Draw a horizontal line and snap to the vertical line. Set the height of the gear as 8 mm. Make these two lines parallel. Make the horizontal line 74 mm. Change the face width to 11 mm. Check the offset distance. It is 3.97 mm from the base to the pitch circle. Close the sketch. Cut the groove. This crown gear is good. Hide the crown gear. I haven't checked the offset distance of the spider gear, and let me do it now. It is 1.39 mm. Also verify the gear height, which is 10.15 mm. Show the spider. Toggle active body. Select this surface. Create new sketch. Draw a circle 6 mm diameter. Pad it 3 mm. Hide the spider. Show the side gear. Toggle active body. Select this surface and create a new sketch. Draw a circle 10 mm diameter. Pad it 60 mm. Hide the side gear. Show the pinion gear. Toggle active body. Select this surface and create a new sketch. Draw a circle 10 mm diameter. Pad it 40 mm. Hide the pinion and show the crown gear. Toggle active body. Select this surface and create a new sketch. Draw a circle 40 mm diameter. Draw two horizontal lines. (10 mm long). Delete the arcs. Pad at 29 mm. Select this surface and create a new sketch. Get external geometry. Draw two arcs and snap to these points. Use polyline to draw the shape. Make these line horizontal. Make these lines vertical. These point seam cannot snap to the points from previous drawing. Make these 2 points symmetric about y-axis. Set it as 10 mm. Draw a circle with construction line. (36 mm diameter). Snap these 2 points to the circle. Seems not have enough constraints to complete the drawing. Snap this point to the circle too. It looks good. Close the sketch. Change Z position to -5 mm. Cut it by 24 mm. Select this surface and create a new sketch. View section. Draw a circle. Get external geometry. Snap the circle to this point. Cut it by 3 mm. Select this surface and create a new drawing. Draw a circle 10 mm diameter. Pocket it. Change to through all. Select this surface and create a new sketch. Get external geometry. Draw a circle 6 mm diameter. Vertical distance 15 mm. Apply pocket tool. Change to through all. Switch to wireframe. Select these edges. Apply fillet 1 mm. Select these edges and apply fillet 1 mm. Switch back to as is. Switch to Assembly4 workbench. Create assembly file. All the parts are in the parts folder. Hide the crown and show spider gear. Select the spider and create new LCS. Select the circular edge at the base and select concentric. Do it again to create another LCS at the same position. Just in case I need to rotate them in different directions. Hide the spider and show the side gear. Select the side gear and create new LCS. Select the circular edge at the base and select concentric. Repeat the process to create another LCS at the same position. It is because two side gears may rotate at different speeds. Hide the side gear and show the pinion. Select the pinion and create new LCS. Select the circular edge at the base and select concentric. Hide the pinion and show the crown. Select the crown gear and create new LCS. Select the circular edge at the base and select concentric. Hide all the LCS. There is a check mark at the crown LCS. Refresh it and it is fine. Add new variables angle and set the initial value as 0. Add other variable rotate to turn the support arm at the crown gear and set initial value to 0 too. Add more variables side 1, side 2, spider 1 and spider 2. All initial values are 0. Also add variables for crown and pinion. Initial value is also 0. Select the assembly and create a new sketch, call it Master Spider. It is for mounting the spider gears. Go to Model and select LCS Origin as reference. Go back to Task and select Plane Face, which is XY plane by default. Open the sketch. Change the value of variables angle to 10 and rotate to 1. Draw two lines from the origin. Set them as 15 mm long. Set the angle as variables.angle times variables.rotate. Make these two lines parallel and close the sketch. Select the sketch and create new LCS, M1 spider. Select the line at the right and select Z tangent to edge. Select the endpoint to move the LCS there. Select the sketch and create new LCS, M2 spider. Select the line at the left and select Z tangent to edge. Select the endpoint to move the LCS there. Hide the sketch and LCS. Select the assembly and create a new sketch, name it as master side. It is for mounting the side gears. Go to Model and select LCS Origin as reference. Go back to Task and select Objects XZ. Open the sketch. Draw two lines along the y-axis. Set them as 10 mm long and the R for attaching the side gear. Select the sketch and create new LCS, M1 side. Select the line at the top and select Z tangent to edge. Select the endpoint to move the LCS there. Select the sketch and create new LCS, M2 side. Select the line at the bottom and select Z tangent to edge. Select the endpoint to move the LCS there. Hide the sketch and LCS. Select the assembly and create a new sketch, name it as master crown. Go to Model and select LCS Origin as reference. Go back to Task and select Objects XZ. Open the sketch. Draw two lines at 90 degrees. Horizontal line 36 mm plus offset 0.61 mm, so it is 36.61 mm. Vertical line 9 mm plus offset 3.97 mm, so it is 12.97 mm. I included offset at the sketch, then I don't need to adjust it when I insert the gear. The line is 19 mm from the origin. It is to place the crown gear 19 mm from the apex of spider and side gears. For the spider and side gear, I didn't add the offset at the sketch and I will adjust them when inserting into the assembly. Either way is fine. Close the sketch. Select the sketch and create new LCS M pinion. Select the short line and Z tangent to edge. Select the vertex to move the LCS to the end. Select the sketch and create new LCS M crown. Select the long line and Z tangent to edge. The LCS is at the desired position. It is good. Change the variables to 0 again. Show the Sketchmaster spider. Insert the spider gear. Select the spider and insert. Parent assembly. Match M1 spider to spider 1 LCS. Adjust Z to -1.39 mm. Insert the spider gear. Parent assembly. Match M2 spider to spider 2 LCS. Adjust Z to -1.39 mm. Show the Sketchmaster side. Insert the side gear. Parent assembly. Match M1 side to side 1 LCS. Adjust Z to -2.08 mm. The position is right but the gears may not mesh, we'll deal with it later. Insert the side gear again. Parent assembly. Match M2 side to side 2 LCS. Adjust Z to -2.08 mm. Side 2 gear meshes with spider 1 gear. So adjust spider 2 gear first. Spider 2 gear is 10 teeth, rotate it by half tooth may work. It is 360 degree divided by 10 teeth and then by 2. It comes up with 18 degree. Go to assembly and then angle in the attachment. Change it to 18 degree. Next one is the side 1 gear. Turn it by half tooth. It is 360 degree divided by 15 teeth and then by 2. That is 12 degree. Now all the gears mesh. Show the Sketchmaster crown. Insert the pinion. Parent assembly. Match M pinion to pinion LCS. Rotate Y by 90 degree. As I have included the offset distance in the sketch, I don't need to adjust the distance after inserting it. Insert the crown gear. Parent assembly. Match M crown to crown LCS. Rotate Y twice. Then rotate X and Z. In fact, just trial and error to get the right. No adjustment for the offset distance is required as it is included in the master sketch. Everything looks good. Select both side gears and change the color to blue. Change the spider gear to amber. Change the pinion to purple. For the crown gear, change it to green. Also change the transparency to 80 so we can see the movement of side gears. Hide the LCS and sketches. Change the crown gear to yellow as the green color is too close to the blue side gear. Enter values for variables. 3 for crown. 12 for pinion. -3 for rotate. 3 for side 1. -3 for side 2. Keep it 0 for spider 1 and spider 2. Select spider 1 LCS. Go to angle in the attachment. Open expression engine. Enter variables.angle times variables.spider1. There is typo in the variable spider1. Delete the variable and add it again, spider1. Update the variable in spider1 LCS. Select spider 2 LCS. In the angle field enter variables.angle times variables.spider2. Do the same for side 1 LCS. Repeat it for side 2 LCS. Same for the pinion. The last one is the crown. Variables.angle times variables.crown. Run the animation. Select angle from the drop-down manual. From 0 to 360, step size 1. The direction of the pinion, side 1 and side 2 gears are wrong. Change variable pinion to -12. Side 1 to -3. And side 2 to 3. Run the animation again. Directions are correct now. Spider gears are not rotating and angular speed of two shafts are the same. Change step size to 1.5 and run the animation. I cannot use bigger step size as the pinion has already been running at 12 times of the variable's angle. With bigger step size the pinion may appear running in opposite direction. Change the variable spider 1 and spider 2 both to 3. As the gear ratio of side gear to spider gear is 1.5. Change the speed of the spider by 3 will change the side gear speed by 2. So add 2 to both side 1 and side 2. Then side 1 is -1 and side 2 is 5. We'll test run is the direction is correct or not. Run the animation. The direction of the spider is wrong. Change to spider 1 and 2 to -3 to reverse the direction. Run it again. It is correct now and shaft at the bottom is running faster but it is not obvious. We'll show it in MP4 to get better idea later. Show the variables again. Change spider 1 and 2 both to 3. Side 1 to -5. And side 2 to 1. Run the animation again. The shaft at the top is running faster. Change the step size to 1 and save it as MP4 video. Use select icon to put the file in the desired location. Enter the file name. Change width to 1920 and height to 1080. Change FPS to 30 and use 1 for the loop. Then click Create and Save button. As the step size is 1 and it will take several minutes to export this file. The export is completed. Run the video. The top shaft is running 5 times as the bottom shaft. Export the videos for other 2 scenarios, which are what I use at the beginning. If you find this video interesting, please subscribe and give it a like. Thank you for watching.